Hello, I'm Yu Hong Chen. I'm an undergraduate student. We come from Department of Computer Science and Information Engineering at National Jinan University. Because I'm doing my mandatory military service, I record a video to introduce our paper. Today, I'm going to introduce my research, the advanced XOR-based visual cryptography scheme with meaningful shares. This is the outline of our report. First, I am going to introduce the introduction and motivation. Second, the related work will introduce two methods. And the third part is our main result. The fourth part is experiment result. At last, I will compare our paper with for the date of the art approaches. Because of the information security is becoming more and more important. Visual cryptography is one of the ways to strengthen information security. The basic concept of visual cryptography was proposed by Noor and Shamir in 1995. However, two disadvantages, pixel expansion and compact design, it needed to make layer scheme impossible to generate the share of high visual quality. The researcher found that there are some ways to increase the visual quality. First, the random grid DEX, which proposed in 1987, can solve the pixel expansion problem. Second, according to the principle, using the OR operation to stake share will cause at most half of image to be completely reconstructed. The research of DEX began to use the XOR operation to replace the OR operation as the operation in DEX. The last is that Noor and Shamir's scheme will generate meaningless shares. Other people will be attracted by the encrypted trace on the meaningless shares. So the meaningful shares are better than meaningless shares. In 2015, Wu and Sun and O proposed XOR-based DEX method to generate meaningful shares. The method of O are divided into three parts. In algorithm 1, the two array will be created to be used in encryption. The algorithm 2 is encryption. And in the algorithm 3, first, user set a parameter beta, and when processing each pixel, randomly generate a decimal d. If d is less than or equal to beta, encrypt the next pixel, else do camouflage to the next pixel. This is the basic schematic of O's method. The principle of it is that they can import one secret and one cover. Then a meaningful share will be generated. N can be 1 to infinity. After staking shares by XOR operation, the original secret can be restored. In 2021, Load and Run modified the O's method and proposed the three new methods. According to the three methods, it would generate three different visual quality of shares and the revealed secret. Among the three methods, the algorithm 4 can completely restore the original secret. As a result, we will extend the capability of Load and Run's research to import n grayscale or color images, to generate n grayscale or color images, respectively. This is a basic schematic of Load and Run's research. They can import n covers and generate the n meaningful shares, which are similar with covers. The meaningful shares can all be different or the same. Similarly, after staking all of the shares, the original secret can be restored. Figure 1 shows the secret and covers which import in algorithm 4, and Figure 2 shows the experiment result. In Figure 2, we can find even if the beta values are different, the original secret can be completely restored. Now, we are going to introduce our main results. In our research, we do camouflage for every pixel. As a result, we will not use algorithm 1 and 2, and Then modify algorithm 4. This is basic schematic of our proposed method. In algorithm 5, similarly, we can import n covers and generate n shares, and the covers can all be different or the same. All images are grayscale. The principle of algorithm 5 is that we choose x from 1 to n such that the difference between the share x and the cover x need be the minimum one. At last, we set share x to other n subtract 1 covers. Do XOR operation with secret. Other n subtract 1 shares are set to be covers. This is the basic schematic of algorithm 6. In algorithm 6, similar to algorithm 5, we can import n covers and generate n shares. The covers can all be different or the same. Similar to algorithm 5, for each channel, we choose x from 1 to n such that the difference between the share x and the cover x need be the minimum one. In grayscale and color images, the PSNR is the well-known image quality assignment metric. The PSNR is range 0 to 50. It is as high as possible. If the PSNR is greater than 30, the encrypted traces on the shares cannot be detected with human eyes. This page shows our experiment result of algorithm 5. S is our secret. C1, C2, C3, C4, and C5 is covers. R1, R2, R3, R4, and R5 is shares which generated by algorithm 5. After staking all shares, the S revealed will appear. Although the PSNR of each share is around 19, we can find a little traces on the shares. To ensure that experiment result of previous page is not spatial cast, we randomly select n covers from 15 different grayscale images and do camouflage with these covers. N is from 3 to 7. This table shows the average PSNR of each case. We can find that as n increases, the average visual quality of shares becomes better. This page shows our experiment result of algorithm 6. The PSNR of each share is also around 19, so we can see a little trace on the shares. Similar to previous method, we randomly select n covers from 15 different color images and do camouflage with these covers. The orange table is the experiment result of color images, and the blue table is the average PSNR of grayscale images. It's easy to see that the average PSNR in orange table is similar to the value in the blue table for each case. In this section, we compare our scheme with other state-of-the-art approaches. The first paper is Noor and Shamia's research. The second paper is O's research. The third paper is Science research. Science extends the capabilities of O's research. The last paper is Low and Run research. The type of images of our scheme is grayscale and color, so we compare the capabilities with other schemes. We can obviously find that even use grayscale and color images, our scheme doesn't have the issue of pixel expansion. We can generate meaningful share, import n-cover images, and generate n-share images. The contrast as defined in other research is decide how human eyes could recognize the reconstructed image. It ranges from 0 to 1. The contrast must be as high as possible. We can see that our scheme is better than others. Thanks for listening.